So, you have a question, shoot. Do you need this?
Thank you.
Good afternoon, my name is Frederick, and my question is for Stan. How do you recruit your crew members?
How do I recruit them?
Yes.
Are you still armed? No.
In most of the boats that I navigate, I get hired to be the navigator. So I guess they recruited me or hired me. On our boat, what I've done so far is I've picked the best sailors I've ever known, including Carl in the corner there, and ask them, and then hope that they agree to come along.
Thank you.
Another question? Yeah, shoot, please.
I've got two for Jeff. Can you talk a little bit about what weather is available,
which I think you guys are providing on the Garmin inReach system? And then the other question is, what sort of weather is Sirius providing that you can get through Furuno or wherever?
Sure. The inReach, Garmin inReach or DeLorme inReach, if it was an older model, they are currently using data, basically GFS data. It comes from a company called Dark Sky. They're bringing that into their particular app. That's only good inshore type stuff, so you're not going to get any real offshore data with that. With that, they push over to us, and we basically reconfigure some GFS, or we're bringing in a couple different models depending on the exact location that you're looking for data, so that we have the highest resolution, most current model available for that particular request. If you're mountaineering, it's altitude adjusted. If you're sailing, you can access the wave data, which is typically WW3. The Sirius system is pretty much GFS data only. They're just kind of pushing it out at a standard resolution for their instruments. There's really nothing special about their data. It's just a pretty picture to really put over your chart plotter. It's not all that useful. It's not real high resolution because they're very bandwidth limited. And I'm sure you'd hear, you know, this guy over here wouldn't really be running these races with the Sirius unit, just because you don't have any flexibility over what type of data you're looking at. And yeah, they could change that at any time. The other issue is the Sirius doesn't work offshore. You get too far offshore and you're out of their coverage area, so you're not going to get any data out there.
But it does get out to something like Bermuda.
Yeah, it does do Bermuda, and a lot of people will use it to get out there, but like I say, it's a little harder to use on a chart plotter than getting weather data onto your computer, where you can use some more advanced navigation software to help you analyze that data.
Yeah, please.
Question for Joe, maybe. Question for Joe about the high res. Just in the last couple of weeks, I think what Stan talked about, I agreed with completely about how good it is. But even in just the last couple of weeks, 2 examples I found where it wasn't 1/3 of the wind strength that we got. The one that might have been more interesting was right on the Columbia River in Portland. And front came through in the morning. It was a Sunday morning. It was a race on the river. The high res showed, a meteogram for it showed a rapid drop-off of the wind down to about 12 knots. That looked solid as a projection, but it built to 34 and it didn't calm down for hours and hours. And that was this time a week ago.
Still is just a model, okay? It still is a simulation into the future.
We were within half a mile of PDX. So, yeah.
So a failure all the way around. Yeah, in other words, yeah, the way I say it. I know my own experience on the Chesapeake, that the character of the shifts and all is excellent. It's superior. when we have wind, it tends to underestimate the wind, you know. But the character, you know, when things are going to change, when the wind's going to fill in, it's awesome. In that example, was there convection thunderstorms around at all? That's just me guessing, trying to grasp at something.
There was a bit of a rain squall that came in from the south at the time.
Okay, and how long did it, so it lasted a long, did it have temporal depth to it? Did it last a long time, the wind?
Yeah, it continued on for a couple of hours.
Couple of hours, okay.
But it was like 34 knots when
Yeah.
12 was-
No, that's a miss, and I sail too, so I know what 34 knots is on a modern sailboat, and it is not much fun. Yeah, it's dangerous, is what I'm saying. Yeah, I don't have an answer as to why. It is just a model. I know when it comes to like when the thunderstorms and all, it doesn't always get the character of the. It gets the character of the convection right, the thunderstorms. It doesn't always place them in the right location because the conditions. You're as close to the butterfly wing, you know, and the flapping as can be. Convection begets convection, and if you miss something in early on, then that's going to propagate through that model run. Did you look at did you look at the subsequent runs at all to see? And we run it every hour to see if it actually caught up, because that's what it's designed to do.
Yeah, it didn't.
It doesn't help, but
I didn't go back. I could have. I should have. I didn't do that.
Yeah, that would be something to do. And I want to kind of agree with Stan. Is those models that's the NAM, the HER. I mean, they're designed really for very, very short term. They're designed for 6, maybe 12 hours, and not really beyond that. Even though they simulate, and I like to use the word, it looks seductive. I mean, it looks really, when you get farther out in time, it looks as good as it does in the short term, forgetting that now you're drifting away sort of from the strength of it, where it's relying on the 0-hour conditions. So yeah, I agree that's why we run it every hour, is so that you're updating quickly. It's designed for aviation and for thunderstorms, which means you have to get the wind right. So you benefit also.
The other one, just real quick, was the other one was down near Ensenada about a week before that. That one was more understandable to me because it was closing the shore, and it was an offshore wind, and it was again in the mid-30s, and the high res was calling for nice breeze of 12 knots.
Oh wow! No, that
that was more understandable to me because of the shape of the terrain, kind of like the gap that David showed in his one slide.
Yeah, which by the way was really clever what he's demonstrating. Yeah, I really like that.
Thank you.
And I was going to add here that the situation you mentioned up here, where you're dealing with a frontal passage, keep in mind the weather systems, because part of what we want to have you folks do is understand the weather systems and not just read the output. Where you had a front changeable systems coming through. We talked about scales of weather systems, and this model is designed for mesoscale. Perhaps there is something microscale going on there that the model's not picking up.
Maybe if I might add one thing as another double check is that HER. I agree completely that the HER is like really the answer, and likewise GFS, at least first 3 days or so, is the best. But on the local waters, in addition to the HER, to gain a little more knowledge, you could also look at the NDFD. Now, it's not good for running models or anything. It's a little irregular at times, but the data is there, and that the local offices are inputting to that one, NDFD, and we can get it. And then I would also look at the National Blend of Models, CONUS. And so if you got the HER, the NDFD, and the National Blend of Models, CONUS, you can look at all of them. And even throw in the 3-kilometer NAM.
To compare. Yeah, please.
Question for Stan. You talked about the historical initialization data for GFS, for example, to kind of look at what races looked like a couple of years ago. Is there an easy way to get that from somewhere, or a piece of software to download that, a service to get that from, or do you have to build that yourself?
It's a little bit easier for the ECMWF, which is odd, because the ECMWF is impossible to get in terms of the forecast, but they make it relatively easier to get their historical data. The GFS data is all available from NOAA, but it takes a fair amount of work on your own to actually build it into a grid file.
Has anybody written that down, or?
Yeah. Is it still the Nomad site, Joe? Yeah. Nomads
Yeah.
is one of the key words in the address for that. You do have it is a little bit arcane to use, and we were talking a little bit yesterday about what is and what isn't about federal programs. That location seemed, in my estimation, to be getting more arcane in their efforts to improve it. So be patient.
Yeah, my question goes back to way earlier in the day, and it's the 500 millibar charts and how those are derived. I'm a little bit of a data kind of guy, and I'm wondering, where do you get the data for 500 millibars?
Well, I'll start on this one, and then I'm going to pass it off to Joe. The old source of data, so to speak, is the weather balloons that are launched twice a day from various sites around the world. Of course, they're going to be very heavily biased toward land locations where you can actually launch the weather balloons. But the weather balloon goes up, carries a sensor, which measures temperature and humidity. It's tracked by radar, and the radar will show the height of the weather balloon and also will derive the wind speed and direction. So when that weather balloon's pressure sensor reads 500 millibars, the radar says, okay, that's at 5,810 meters, so we're going to record that as a 500 millibar height. We know which direction it's flying at that point, so we can derive the wind at southwest at 50 or whatever it is. And that's the backbone of the data. And that's been the backbone of the data for a long time. Now there are, over the oceans, of course, there's less of that. And there are other ways that we can use satellite data, and I'm going to pass the mic off to Joe in a minute because he knows more about this than I do. But if we know the wind speed and we have known data points of the 500 millibar height, then we can work backwards and get the height field. So, and there's more sophisticated ways of analyzing the data. The weather balloons are the backbone, and the satellites are helping. And I'm going to let Joe expound on that.
Actually, your answer is really good. So typically what you're looking at when you see a 0 hour 500 millibar, remember we run an assimilation with data. You know, we bring the data in, we basically define the initial state of the atmosphere. Well, we don't do that just at the surface. We do it through the whole volume of the atmosphere. And that's kind of the starting point. And the radiosondes really do, over land anyway, really play a key role because it's think of it this way, is when we satellite data, a lot of times we actually have to reference the model to get to complete the picture. We don't have that, we might have a temperature, but it might be that we have to assign a height with that temperature, and we have to have a non-independent source, which is the model, in order to determine that. Radiosondes are completely independent. That it's a measure in the vertical, so it's a way of sort of keeping us grounded in defining things. That's pretty much why they're still around, that we still use them. But yes, basically what you're seeing even over the oceans, especially over the oceans, in the 500 millibar height field, and there are a lot more fields than that. We just do the height field. It basically is the model analysis, or in the forecast time. We can't do any better as a human. There's no way we could do any better, and the time that it would take to do that. So yeah, it's a model analysis.
Yeah, Chris.
CCA is doing a cruise in Majorca in September. I was wondering, with all you weather jocks up there, what your thoughts are about the danger and predictability of resaca. Are you familiar with that?
Scirocco?
No, resaca.
Don't.
No.
No.
We experienced this, I guess about 12 years ago, out there in the Port of Androx. It was kind of a blustery day, and we side-tied. We were kind of the last boat in the marina there. We side-tied to the seawall, and everybody was asleep. I got up and started walking on the docks, walked all the way out to one dock, just looking at the boats. Coming back, it's a concrete pier. I could see the water level rising. It it was about maybe 5 feet below the surface as I walked out. And as I'm walking back, and this was, probably 800-foot long pier, I could see it rising. By the time we got back to the boat, I woke everybody up because the boat was now starting to float over the seawall. And so we got up and we got tires, and it was a total mess. It was not predicted by anybody there. And a lot of boats were seriously damaged because they floated above the concrete pier, and then when it went down, came down on their swim steps and their props. And this phenomenon, it did maybe a 10-foot gyration over about a 30-minute period, and it lasted for hours. And we were constantly pushing the boat off of the seawall. The entire parking lot flooded to the tune of about 18 inches, shorted out all the electrical, drowned a few cars. And anyway, just wondering if anybody heard of that before. I've seen a scientific paper, about 25 pages written about this, but just wondered if you guys were aware of it. RESACA, Resaca.
And the country, where were we?
Mallorca.
Mallorca, again. Oh, Tony.
Okay. It was incredibly dramatic. We established our own Resaca meter, which put a batten horizontally across the boat so we could measure it against something that was on the dock. And it was just an amazing amount of movement and a lot of work for hours and hours.
So let me give this a shot, and I apologize if I'm kind of out to lunch. So in the U.S., we've kind of identified a phenomena called a meteor tsunami. And I can't stand the phrase because right away there's a picture in your head. But fast-moving pressure systems like thunderstorm lines can actually manifest themselves into a pressure wave into the ocean. Some on a scale that is larger than swell and smaller than, say, storm surge, and certainly smaller than a tsunami. We had a derecho that had moved off the East Coast several years ago. Actually, it was when the Annapolis to Newport boats were returning from to Annapolis from the Chesapeake, and took great pictures of this derecho, a line of thunderstorms moving offshore, in a phase speed that basically triggered this pressure wave that then manifests itself in the ocean, so that actually, like Charleston, Bermuda, Maine, all had a rapid tide rise and then subside relatively quickly. So you get a disturbance going in a certain speed, and it'll trigger something that you don't quite, it's out of the norm. In other words, that's what I'm assuming. I mean, the Med is a phenomenal place. It's one of my therapy things at lunch, aside from looking at the Gulf Stream and ice, is to actually look in the Med at the intricacies of the wind fields and the severity of the wind fields and the sharpness of the boundary. Gulf of Lyon, Gulf of Genoa, you will see outflow that you'll go from 10 knots to 40 knots in a very, very short distance because it's an outflow like you were showing, with a gap. But this is what it sounds like, some manifestation like that. It sounds like something bigger because of where it is in the basin than, say, a SAIS, where you would more or less kind of notice that, on the ends, like what Lake Erie does. Yeah. Anybody else want to give this a shot?
Given Mallorca, it's a little bit of an unusual situation, but I agree with Joe that we can get that kind of pressure forcing, and then we can set a basin in oscillation. And there are it's like getting the bathtub going. You can get it just going just so, and it can amplify. Marian's formula gives you the Sailor Basin, but Mallorca is sort of sitting out there. You'd have to get the whole of the Western Mediterranean going to get that.
Before we went out there, I read up on things and ran across an article about it having occurred, 10 or 15 years before in Puerto Mahan, in Menorca. And so I was aware of the phenomenon. So it was just a shock that we experienced it. Afterwards, talking to people who'd lived there all their lives.
But you would normally have quite a system going along with it.
It wasn't. It was kind of a gray, drizzly day. It wasn't a big deal.
Yeah, so it sounds like it might have been a far field.
Well, that's
an event.
Actual weather that produced it may have not occurred where you
Right,
were. It may
no.
have occurred farther north or northeast in the Gulf of Lion or
Right.
over toward the Gulf of Genoa or something, and it set that wave in progress. So it's, and that's much what the situation that Joe was talking about. I remember that one because in Maine at the time there were headlines, you know, all of a sudden the tide in Booth Bay Harbor went up 3 or 4 feet or something at a weird time, and there was no weather associated with it locally. So that may be
Right.
what you're talking about.
Thank you.
Yeah, Doug.
This is for Stan. You asked for it. You said in the record attempt with PlayStation crossing the channel was the second stupidest thing that you ever. I mean, for those of us who've done lots of stupid things, and to make us feel better comparing ourselves to you, would you please share? Would you be willing to share what the stupidest thing was that you ever done? Thank you.
Well, it was largely the same crew, but Steve Fawcett owned the America's Cup catamaran Stars and Stripes that Dennis Connors used in the legendary America's Cup off San Diego, where he, raced the catamaran against I think actually Carl sailed on that boat. But nevertheless, we decided it was a good idea to race that America's Cup catamaran in the Long Beach to Cabo San Lucas offshore race. And that was the stupidest thing I've ever done.
Thank you.
Yeah. Buddy in back? Yeah. Oh, another one. Right there, go.
I've got more questions than
Yeah.
This is one for you, Frank. You spoke about the upwelling here off this Washington coast with a sort of a prevailing southwesterly and a switch with northwesterly, and you talked about that upwelling change. What sort of time frame does that change occur over?
Well, it depends on the systems that we're looking at. Generally, what you have out there is a northerly flow, the air heading from here down south. And as it's going down south, it's pushing the water, the surface waters, offshore. So there's a fair amount of fair weather seasonal upwelling. When you get a storm and have a southwesterly flow blowing south to north, then you get the downwelling. And the time scales out here, I think, if we looked at it, prevailing conditions are upwelling. Most of the time you have upwelling. It's as the system moves through and how long that system goes. If it's a relatively short system and replaced quickly by a northerly wind, you won't see much. I'm armed, actually, I think, right? So the time scale varies, depends on the systems as they move through.
But it's on the same sort of time frame as the storm.
Right.
It can literally go from downwelling.
As the duration of the event.
Upwelling to downwelling.
Right.
Across that event.
It can happen fairly quickly.
Thanks.
On that.
So I'm going to, a colleague of yours. So I'm on a NASA winds team. In fact, while David was talking, I was emailing somebody with a picture because they're actually the source of those tiles that was, anyway, so I'm on a NASA team. And one of the members, Melanie Fewings, has done some really nice work. We had an opportunity a few years ago where a scatterometer, a quick scat device, was actually flown on the International Space Station. So the A-scats that you see and the others that are in a polar orbit pass over the same point over the ocean, thereabouts, the same time every day. In fact, the A-scats are what they call on a 9:30 orbit. That's local time, basically. So every day at 9:30 and again at 21:30 local time is when they pass over. Okay, so you don't get an idea of the diurnal fluctuation of basically the heating of the land and all that. Rapid Scat actually revealed that, and there is a cycle to the upwelling, to the migration northward, the reestablishment of the winds from Cape Mendocino to Cape Blanco.
Right.
And she has a really, really nice paper about it. I can't remember the details, but I just remember it was a really clever application using the space station, which was just, you could actually recreate a diurnal cycle.
Right. This data. Yep. Thank you.
This is a question for Joe. So climate is changing faster than ever recorded, arguably. How does that affect weather forecasting and models? Do you see any kind of effect? New phenomenons?
I'm going to get a little bit over my head, but I'll give this a shot. Okay. The basic equations aren't changing. So that's the good news, okay? The starting point is changing. Reference to the past is becoming harder and harder to do. So comparisons in going back in time, where basically we are changing sort of how we're doing that, because we have to go back shorter in time in order to have something that's relevant. There are things that we do on the climate side, so beyond the day 8 forecast time, where we actually are referencing the past in order to get the signals. That's challenging. So we're fortunate, and when I said we're in a remarkable age, we're very fortunate that we have a lot of instrumentation that's flying in space so that we can stay relevant on the changes, even though we may not understand them. But as far as the day-to-day weather models, the equations are set. It's the input parameters that are changing, and they should be able to handle that, at least in the time frames that we're making decisions, on sailboats. Mm-hmm. The farther out, that's a bit of a different beast, and I know that there is sort of dancing going on as to try to adjust things. So can I get off the hook now with that? Thanks.
One slight disagreement. It depends how far back you go on all this. The equations, the problem that we have with turbulence is that the equations of motion, the fundamental equation is the momentum equation, which is F equals ma. You can remember that easily enough, I hope. It's enclosed. There's an infinite number of terms because of the nature of the turbulent flow. So what do? We leave in these smaller and getting smaller and smaller yet and smaller out to some point, and then we truncate. We cut it off. Well, there's maybe a lot of things going on down in those butterfly wings in the far end of the equation. Over the last 20 years, we've gotten better and better at parameterizing and working with the structure of turbulence. So there's been a fundamental improvement, even in the fundamental equations, because of the way we're handling turbulence. That is improving. The other end of it, I hope you see with better and better computers, is the resolution is getting smaller and smaller. We, after all, only care about a 50-foot patch of ocean. And you didn't see many resolutions that were down to the 50-foot sort of a thing. So resolution is another issue that's really gotten better.
And I'll do I don't know if it's a plug or whatever, but so I know we talk about the GFS as being quarter degree. That's the output. It's actually run at half that, but we don't output it. In fact, Nick White had asked me a question a couple of weeks ago, and I actually went to the head of our modeling. And because we have an enormous amount of stuff going on right now, we're trying to upgrade our modeling system to something called the Unified Forecast System and move into a coupled environment where we're actually modeling in the forecast mode, the ocean, waves, and atmosphere, and ice all at the same time. It's what we really need to do. So that's a focus area. So there is no intention right now to go beyond the quarter degree output, even though internally that's what the model is running at. I was a little disappointed in that answer, but we'll see. I'll ping again.
Yeah, and Nick White is Expedition.
I think so, yeah, I think so.
I have a question for Frank. During your presentation on currents and tides, you mentioned that high and low pressure systems will affect tidal range.
Yeah.
What scale are you talking about, millimeters, centimeters?
The pressure effect on sea level elevation is generally small compared to the setup produced by wind. So we're looking at millibar changes is in the tenths of inches kind of thing in elevation. It's quite small. But you can get a foot of change depending on, you get a bomb come along, 20 millibars down, you can get yourself a foot of water elevation change. It's on that order. But if generally with the bomb, you might have 30 to 40 knots of wind. I can't use that bomb anymore, right? A rapidly developing system, whatever it is. Rapid intensification. You'd have 30 or 40 knots of wind. You'd have more setup associated with that than but because of the pressure change, than you would have.
But Ken and I, I'm going to hand it over to Ken in a second, but so I live near the Chesapeake, and the Chesapeake is very, very reactive to pressure changes and wind. And an example, did anybody go to the Annapolis Boat Show this year? Anybody here? You were there. Okay. Did you wear your boots? Oh, yeah. So there was a storm offshore. Annapolis, we were under the high. We were not under the high, we were in between the high and the storm offshore, well offshore. But it persisted for a good several days, and it also timed with a favorable spring tide moon. And do not call it king tides. It just drives me nuts, but that's okay. It's a thing. So basically, for 10 tidal cycles, the Chesapeake was well above mean high water, well above highest astronomical tide, where it was never even returning back below the highest astronomical. So Annapolis was flooded downtown. I think it was Saturday afternoon. Had to close the boat show down because basically all the tents, all the vendors, all that was flooded. Was in the bay. The boats were fine because they were out on the docks. But okay.
So you get a slosh.
Yeah, you get and then on the other side of it, basically, when we have strong high pressure building in and a northwesterly flow, you'll get a drainage. We call it a blowout tide.
Right.
Having done what they call tide jobs when I was driving tugs back a long time ago, that it used to limit where we could go into places because basically there was no water. The dispatcher always said, well, if there's no water now and there's no water at high, well, you can go in now because what's the difference? As opposed to the fact that there was no water.
Put down the wheels.
If I may make a note on this, about you're curious about the actual numbers, the NOAA Tide and Currents page has a link to what they call water levels. And it's actually a beautiful plot where and I get my colors mixed up, but there's like a blue plot which shows what the tide height should be at a certain place and time, a graph. And then there's a red graph which shows what it really was, what the water levels really were at that time and station. And there's quite a few stations around the country where they do this. And right underneath it is a plot of the pressure versus time. So then you can compare this, how much the pressure is relative to the norm. The tides are computed based on an average, seasonal average pressure. But then if the pressure is unaverage, you'll see the water go up and down. I mean, you can measure it and see it in these nice graphs. It's effect that was known to Fitzroy. Our Fitzroy, and they had a saying in those days, the fog nips the tide. The fog nips the tide. Now, they were almost right, you see, because it wasn't the fog, it was the high. The high pressure that caused the fog is what nips the tide.
Right.
Nice
NOAA Tides and Currents.
You were actually looking at Joyce, this morning, a fair number of the plots that I had up there came from NOAA Tides and Currents.
But I want to add, too, that it's not just the pressure change, but it's the wind. An onshore, offshore wind will also raise or lower the water level.
That's what I said.
And it doesn't have to be windy at your location, particularly in the case of a bay or an inlet. It has to be windy offshore. And if that's sending the water in, then you're going to see that. Because Frank is right that the change on pressure alone is usually measured in inches.
Right.
And in places like Maine, where the tidal range is 10 feet, it's not that much of a difference. But if you've got the onshore wind, that's going to have a significant effect as well.
And when it comes to onshore, it doesn't have to be onshore. The transport is actually perpendicular to the wind. So you can have a northerly wind off the East Coast, and that actually is the most effective. And that was the case with the storm system offshore back in October. That northerly wind basically is pushing the water and holding the water into the bays.
think we have time for a couple more.
Just a logistic question. Am I right that all the slide decks are going to be on the CCA website?
No.
Do we get them, you've referenced a couple times that we'll have access to some of the slide decks? How do we get those?
There's a video being made, and the video will be available. The video will be available. As an engineer, we thought we could produce a video. You got a video, there it is, and we can edit it and get it out in a couple of weeks. It hardly ever works like that, because there are other things that go along with it. But it'll get out just as quick as we can. Now, speaking of videos, I hope you did take the advice and take a peek at Ken's stuff before you came. And while you did it, you saw that there was a number of other subjects in there, some of his oceanography and one on communications. Because Jim Kornman's presentation on communications very nicely complements Jeff's. Jeff really brings us up to date on the satellite that Jim didn't have back 2 years ago. But Jim adds in HF, VHF, everything from just short of wigwag, okay, which also still works. A lot of us still have single sideband systems. That's it. We're using them with some success to download a lot of this information with Pactor packages and the rest of it in there. So it's worth a read. Don't downplay the need for communications. Yeah, one last question. Next to Joyce. Oh, I'm sorry.
Sorry. I've heard a fair amount of mention of the program. Oh gosh, what are everybody's been using? Expedition. Thank you. Is that considered to be the best way to sort of bring all this information together to analyze it? I mean, I'm interested in being able to use the 500 megabar charts, the OPCs. Can you overlay all of that information in Expedition? Anybody who, yeah.
Look, the place to start is to start. There's nothing wrong with pencil and paper, all right? Get out the charts. A lot of us on a short race may not go near Expedition. Having said that, it's a very powerful tool. It is a little pricey, about $1,295 or so to buy the program. But the tool really allows you to get into the heart of your system, that is your polars. You can go out sailing and you can revise your polars, your instruments and instrument calibration, the need for, and then some of the historic information and evaluations, run simulations on different races. That's all there. It's handy. This is not something just like the tuning up. You know, folks don't know how to use a satellite phone. You're given a phone here, dial a number on it. We talked about trivializing. This is in the same box. You don't buy Expedition and tomorrow morning get full value out of it. It is a lot of work, very much worthwhile. We use it for a lot of things. But there's also nothing wrong with starting. Get the 500 millibar. Get the latest Gulfstream images or the current images you have out here, the weather for your track, and lay them out on the table and start figuring out routes. And then start applying some of the programs and apps.
All you want is to look at weather charts. What viewer would you recommend?
A view?
So a lot of the standard weather facts or weather charts, that you download them just as image files. So you don't, from NOAA, or whatever source. They're traditional, black and white, or you can get the fancier color ones that David was showing, which are great. There are software packages out there where you could geo-reference those and do some analysis, with some extra tools. And to talk about the Expedition software, there are many other grid viewing software packages out there. We create one. There's a lot of free ones out there and stuff. So if you're just looking to, download this data and play with it a little bit, look at what it's showing you, put it in motion, layer a couple, multiple parameters on there and see the correlations. There's a lot of tools out there for doing that, everywhere from free on up. So you don't, you're not having to commit to a $1,300 software package. You can start somewhere down lower and just use that to, play around with a bit.
David?
Yeah, I was going to mention that, like the one that I showed was a sample from Expedition that has this wonderful feature of downloading and georeferencing maps and then overlaying the model grids on top of it. The free program, open source program, OpenCPN, will do the same thing. I mean, it's a very, very nice feature. And then for looking at the GRIB files, for the PC, there's a free program called XYGRIB, not to be confused with ZYGRIB, which is the forerunner of that one. So the XYGRIB is a very nice PC program that both downloads the data. It won't show the maps, but it'll download the data. And for a very nice Macintosh or iPad program, there's a program called LuckGrib. And LuckGrib has beautiful displays of data and a remarkable a set of sources of data.
Right. I'm afraid we have to close this fun out. You all and we all can talk about the subject all night long, I'm sure. We have to be out of here by 5 o'clock or so for the conference.
Let's give a big hand to Frank and all the guys. Thank you very much.
Thank you, Kevin.
Special recognition to Frank, actually, because sometimes at these events you get a moderator in here who's, well known in the circles and things like that, and then he swoops in and he does his thing and introduces everybody. But in this case, we didn't have that. Frank organized this whole thing. He recruited each one of us to be here and built on what we did a couple of years ago. So this day is really thanks to Frank's work over a long period of time. So
Thank you very much.
Thank you very much.
Thank you very much.